Hello, this is the introductory video for spring 2016 covering the ME30 Arduino Lab Kit. Most of you will be purchasing a kit to use for ME30 this semester, and it'll get used for probably 4 to 6 or 7 weeks depending on exactly what Brian's got set up in the schedule for you this semester. I'll be selling kits in lecture, the first lecture this week, which is Wednesday, and I'll also be on campus Thursday and Friday. I will warn you right away that I am not going to be in town beginning Saturday, and I will be away, not returning until February 18th. So if you're going to buy a kit, and almost every one of you will be wanting to buy a kit, you really need to do it this week, because if you don't get it by Friday, you're not going to be able to get one until at least February 18th when I return. So the price of this semester's kit is $65. However, if you buy it Wednesday, Thursday, or Friday, I'm discounting them to $60 as an encouragement for you to go ahead and get your kit all lined up before I leave, and so that you're ready to go for lab the first week that you use the kit, which, I don't know, maybe week 3 for you. I'm not exactly sure what the syllabus says. I'm sure Brian will be talking about that in lab or in lecture this week. So it is possible, I'll tell you, that it is possible to borrow kits from other students that have taken ME30 in the past. That's a perfectly reasonable thing to do. I will warn you that for a lot of students, it doesn't seem to work out that well. Part of the reason is that the past students are using the Arduino for other things, or it's been built into a project and they don't want to take it apart, or they've lost or maybe broken or fried some of their pieces. So some people don't have intact kits, whether they took them apart intentionally or they destroyed them. But I think a lot of the problem is that students are using them for either ME106 or they're using them for other courses like 154 or the measurements class that you guys have to take, or maybe some other class. Or they've built a project on their own since they've taken 30 or 106, and they don't want to take it out of the, whatever fixture it's in. So every semester, probably about a third to a quarter of the students think that they can get by after the first week or through the first week without buying a kit, and almost every single one comes back to me over the next few weeks through the duration of the Arduino Labs to buy a kit. So the only downside with that is, besides the scheduling conflict I have from the 7th to the 17th of February, the other downside is that you do miss out on the $5 discount. $5 isn't going to break the bank, but $5 is $5. So use your best judgment. If you think you're going to be able to borrow a kit from somebody else, from a friend, enemy, whatever, you want to do that as soon as possible this week, because if you can't make solid arrangements, like if you don't have a kit in hand, you might want to assume that it's not going to happen, and you should consider buying a kit before Friday. I'll announce in lecture when and where I'll be after Wednesday's lecture, so that you can buy kits. I realize a lot of you won't be necessarily prepared after lecture on this first Wednesday, but I will be around the rest of Wednesday afternoon, and I will be on campus probably both Thursday and Friday for a decent chunk of time, so that if you can't arrange, you don't have cash on you or whatever on Wednesday, there will be at least 2 more chances to catch me before I go on vacation. I don't know what the first week is you'll be using the kit. I'm sure Brian will discuss that with you on Wednesday. So what I'm going to do is, well, first thing I'm going to do is I'm going to apologize for these hideous shadows, but I really only have one good point source of light here. I'm not a professional videographer, what can I say? So this is what the kit looks like for this semester. And if you're going to try and borrow kit pieces or a full kit, or what seems to be a full kit from a past student, I'll let you know what the last, I think this basic form of kit's been used for the last 2, maybe 3 semesters. So this kit is a 3-board stack. This is the last semester's kit, exactly last semester's kit, I believe. And the 3 boards look like this. And You see I'm being careful. I'll explain to you why towards the end. Okay, so this bottom board is the Arduino board. The Arduino is a microcontroller board. It's got memory and all the I/O you need to basically be able to sense things from the environment and to be able to cause things in the outside world to happen, whether it's turning on and off lights or making noise or spinning motors or whatever. But this is kind of the key board. These boards are clones. There's nothing wrong with being a clone. The Arduino team that designed the board in the first place always intended for the boards to be freely clonable. They're what's called open source, which means the design is not licensed. You can go ahead and make clones that are pretty much exactly or any variation of their original design, and they're totally cool with it. There are some pretty wild designs out there. There's probably up to 40 or 50 variants of this board that people have designed, sometimes with extra functionality on them. Sometimes they're stripped down to keep the cost even lower. But for the most part, what you are looking for for this course is a board that claims to be an Arduino Uno compatible. Uno is the one model of Arduino board. There's probably 12.5 different Arduino branded boards, but what you're really looking for is the Uno. The reason for this is that all the labs and components that you're going to be using for ME30 and ME106 are 5 volts, and a lot of the other boards that are in the Arduino line aren't 5-volt boards. The only ones that are, off the top of my head, are the Uno, the Leonardo, and the Mega. And then there's some really old series boards that probably haven't been made for 5 or 6 years that predate this board that are compatible, but you're pretty much only likely to see Unos, Megas, and Leonardos in the wild for the most part. It's important if for some reason you're going to buy another board, especially to replace this board this semester. If for some reason something really bad happens to your board, that you're going to want to get an Uno compatible. So what you're looking for is, if you're going to try and score a kit from somebody else, is 3 boards. If for some reason they took apart their top board, this board, I probably still have some of these boards that I can make. So if for some reason you can borrow this from somebody else, then you could purchase one of these separately, and I think these are about 16 or 17 bucks to buy separately. So you could save yourself whatever, 40 or more bucks if you can borrow these pieces from somebody else, and that'll minimize your investment. I will tell you that basically all or most of the parts of this kit are going to be used in ME106. So yeah, you're spending $60, $65 this semester for this kit, but as long as you don't ruin them, you're going to be using these things again. And other students, like I said, have used these in other courses. Maybe I haven't said that, but some students use these for their measurement courses, or they use them for automating maybe some motion in ME154, the mechanics, what is it, the mechanisms class that Dr. Perez usually teaches. So like I said, I'll warn you that a lot of people do use their kits, and so they may not be available for you to borrow. But feel free to go ahead and try and score a kit from somebody else if you think you can do that. So enough of last semester's kit. This is this semester's kit. It is a 2-board stack, and because actually it's a 2-board stack versus 3, I was able to wring out some extra cost, and the kits this semester are actually $3 cheaper than the equivalent kit last semester. Last semester I had multiple versions of the kit, plus I had older ones from the previous semester that I offered at a discount, but this semester there's really only going to be one choice, and the reason for that is 85% of the kits that I sold were this version of the kit. There was a slightly cost-reduced version of the kit that I offered last semester that didn't have this rotary knob on it and didn't have this connection block, and there was one other piece that it didn't have. Oh, there's a little test hook on here. And I offered those at a $5 discount, or they were $5 less than the deluxe version of the board, but everybody pretty much came to me and said, I want the deluxe version, let's just go ahead and do it. And so because of that feedback, I'm basically not doing anything but what was last semester's deluxe kit. So last semester's deluxe kit was $68. This semester they're $65. And like I said, if you score the discount, the first week they're $60. I will take this apart, although there's really not much to see. The board that's on the bottom is the exact same one as last semester. And the top board is, other than the color, is functionally equivalent to what these two boards were here from last semester. You can see that this piece over here is basically globbed onto the side of the old board, the last semester's green board. So this kit was designed so that you can reuse the laser and the servo. These two, the laser is hot glued onto the top of the servo, and the servo itself is also hot glued onto the top of the sideboard. And this board can also be snapped off. I don't know if you can see in the video, you probably can't, but there's it's been routed so that there's only a small tab that joins the left side of the board to the right side of the board, and you can actually snap off the right side of the board if you choose not to have the right side connected after you get out of this class. So sometimes it's nice to not have this stuff in the way. It is nice to have it in the way for ME30 because you don't want to have to be connecting any of these parts up, and that's part of the reason why we've pre-assembled all these things for you. So part of taking the kit apart at the end of the semester would be, if you, like I said, if you choose to, is there's some spring tabs on here. You just press these down and it releases the two wires from the laser leads and allows you to basically just pop off the laser, which is going to end up looking like this. Last semester you would have actually had to snip off the wires from here on the board where they were soldered to. And similarly, just like last semester, you can unplug the servo motor off of here and then pop the laser using the hot that's connected with hot glue off of the top here. And you basically end up with this on top of this, which is a nice compact package and is a little bit easier to incorporate into projects. The reason why this is built the way it is you'll see in Lab 4, and I'm not going to have the opportunity to demo it to you today. But Lab 4 makes use of all the components pretty much on the extension for this board. And if you want to actually see a demo of what you're going to be doing, take a look at the video that I did last semester, which Brian still has a link to on his website. So check out the Spring 2015 extended video that I'll warn you runs about an hour, so you can skip through it. A lot of the content that you're getting in this video is going to be covered in that one. But I probably elaborate on a lot more things in that video. So if you're interested in more of the background or more of the details about what's on the board, feel free to check out that video. I'm not going to do a demo this time because I want to keep this video shorter. A lot of people found the video last semester to be too long. So quick overview of the board. This board has 4 push buttons on them. It's immediately above each push button is a red LED. There's a switch here that switches back and forth between the 4 LEDs and this single red, green, blue LED, which once you see it, you're going to see it's pretty darn bright, and it's a pretty nice little LED. But this board can only talk to either the 4 red LEDs in a row or this red, green, blue LED at a time, and you have to use this little toggle switch, slide switch here, excuse me, to switch back and forth between the two. There's a connection block up here that has that you can stick wires into and run them off into a prototyping breadboard. All 3 of the 3 volt, 3.3 volt, 5 volt, and ground connections are on this. And the reason why this is included is that it's really nice to have some sturdy connections for making power connections to your breadboard. And this prevents those connections from coming apart and inadvertently sometimes shorting a board. Which I actually, the only Arduino that I've ever fried was from having a loose power connection fly around the board, touch something else, and the board was never the same after that. In fact, it wasn't usable at all. There's a temperature sensor down here on the board, and there is what's called a rotary potentiometer here. A potentiometer is a variable resistor. It's basically an old style volume knob. If you've ever had a transistor radio or any old school portable audio device, radio or whatever, Discman from the 90s, this little knob will be very familiar to you. There's a rotary encoder on here, which is basically a clicky knob. You probably can't hear it. Let me, which is very similar to the knob you'd find in AV equipment or your car radio, or any sort of, if you've got any sort of MIDI accessories, they often have rotary devices on them, rotary controls on them that are rotary encoders. There's a speaker on the board. There is a 3-pin connection for hooking up the servo motor. It turns out this 3-pin connection that's down here is functionally exactly the same as this. The reason why it's duplicated is if you choose to take off this board, you will no longer have a servo connection for this board, and you're going to just be able to take your repurposed servo and plug it into this thing, and it's usable on this baseboard. And I think the last useful device on here is in the middle. There's a light, ambient light sensor. This is actually changed. It's the only thing. Functionally, it does the same thing as last semester's, but I'm getting away from using the one that's on here, which is a 1/4-inch oval-shaped thing, in lieu of this, because it turns out this, even though it's more expensive, is easier for me to manufacture because I don't have to hand solder these things on. And that was actually part of the cost reduction for this semester too. So this is a phototransistor versus this device, which is called a photoresistor. You'll learn a lot more about photoresistors in ME106. And phototransistors fundamentally work differently, but they end up doing the same thing. They allow you to kind of measure light levels to determine whether it's dark, really bright, or somewhere in between. And kind of the last thing I think that's on this board that's worth pointing out is the reset button, which is down in the left-hand corner. It's a nice small button, so you're very unlikely to inadvertently press it when you're, whatever, doing project-y things. So that is pretty much it for this semester. Once again, don't, actually I don't know if I mentioned this earlier or not, but I highly discourage you from taking the top board and the bottom board apart. The reason why I don't know if I mentioned it is this is like the 4th take of this video, so I don't know if I mentioned it in this take or not, but I discourage you vehemently, well, not vehemently, greatly from thinking you need or want to separate these two boards. The only reason why you would ever want to separate these boards is if there's ever a question after you've swapped your board with someone else's or your computer for somebody else's to try and narrow down what the problem is. The only reason to ever separate these this semester would be is if you question whether something's gone horrifically wrong with the top board or the bottom board and you're trying to isolate it to one or the other. So the only thing you might want to do is take off the top board and see if whatever problem you're encountering is, if it persists with the top board disconnected or not. So I'm going to show you how to disconnect these. Like I said, I recommend that you don't do this, but and the reason for this is that there's 32 pins that join the top board and the bottom board, and the board pins are pretty long. So if you're not careful, it is simple to bend them. So I've taken apart boards hundreds of times. So I've gotten pretty decent at it, and I'll also let you know that I've been doing other demos with this particular board set, so it's easier to get these apart than some of your kits are going to be. So what you typically want to do is you want to, a little bit at a time, you want to separate either this row from this set by just a millimeter or two, and then do the same for the other side. Typically I spin it around and pull it apart maybe a millimeter or two, and then I flip it back around, do the same thing, and I do this 5, sometimes 10 times until I get the boards apart. What happens, and a lot of you are going to do it, is what happens is that there's so much surface tension, so much friction on these 32 pins, is that if you try and pull them straight out and you're not extremely careful, inevitably what's going to happen is that they're going to come apart like this, or they're going to come apart like this, and you're going to see the last 2 pins on one side or the other, depending on exactly how you've yanked it out, you're going to see them get bent. And if you do that enough times, every time you push these things back in, they're essentially going to be reaming out the female connectors, and eventually they're not going to make a very good connection. So even though it kind of looks like this thing was designed, this Arduino board was designed to just, oh, plug in, disconnect, plug in, disconnect, plug in, disconnect. These things, it's not really meant for more than probably a couple dozen insertions. And after that, you're going to probably wear out these connectors. So for the most part, what you do is you put together a project, and you stick these things together, and you leave them together. And that's what you're going to be doing for ME30. And not until ME106 are you likely to have a need to take these things apart. The reason why you might is that there's other people's boards that serve other functions, like maybe wireless networking or wired networking, or maybe stereo audio or motor control. You're going to maybe want to take this top board off, stick that board on here, and then if you choose to want to use this board would go on top. If you notice, all the action on this board, you have to have access to the top of it, otherwise it's not going to be very useful. If this board is an underboard to something else, you're not going to be able to get almost all the interesting things. You're not going to be able to see the LEDs. You're not going to be able to press the buttons. You'll be able to twist this. You depending on exactly how the board is made, you won't even be able to stick it on this board because the rotary encoder will be in the way. So this always wants to be on top, don't we all? So that is pretty much it. I think that's everything I can think of to mention. Don't separate the boards. Catch me the first week during class. And after I return, you'll probably see me show up and lecture for a couple of weeks. So I will, for the most part, be available via email, even in the 7th to the 17th while I'm away. So if you've got any questions, feel free to go ahead and send them to me. You'll have my email address in lecture. And that's it. So I hope to see most or all of you sometime this week. So that's it. Take care. Talk to you later. Bye-bye.